Alright, I have rewritten the formula that we just derived, and now we're going to focus on this one. But I'm going to generalize this term, and I'm going to call it dst over dsk. Alright? So, dst, dsk, and here we're going to apply the chain rule. So I'm going to divide by st minus 1, st minus 1, ds t minus 2. Okay, and I can continue until I have dsk here, and this is one more, so this is dsk plus 1. Alright, so this we can write as a product of from j equals k to t minus 1, yeah, from ds j plus 1 dsj, right? But this, of course, we can also write as dsj over dsj minus 1. Okay, it's exactly the same. Alright, so now we have the pre-activation. We're gonna call z of j. Remember here the your si is gonna be an element of d-dimensional space, yeah, and also your pre-activation, which we call zj in our case, is also an element of Rd, and Sj is actually the sigmoid of Zj. Yeah. So pre-activation Zj equals Uxj plus Wsj minus 1 plus B. Yeah. Simply the formula without the F or the sigmoid in the front. And then we have Sj equals the sigmoid of Zj. It's just applying the activation to this one. Alright, now let's go back to this one there, dsj to dsj minus 1. And now I'm going to bring the zj in there, chain rule, dsj, dzj, and then dzj with respect to dsj minus 1. Alright, so now Zj is a vector, an element from d-dimensional space, equals Zj1, Zj2, all the way to Zjd. Yeah, but the Sj is also an element of the d-dimensional space, and this is sigma Zj1, sigma Zj2, all the way to sigma Zjn. Alright, so this one here then becomes dsj, dzj. Yeah, this is a matrix. We have dsj1 with respect to dzj1, dsj1, dsj2, sorry, with respect to dzj2, yeah, and then the dsjd with respect to dzj1. Okay, and then here at the end you have dsjd with respect to dzjd. Yeah, and here basically this would be 1, yeah, Sj2, yeah, does not depend on Zj1. So these are all zeros. Yeah, so this is going to be a diagonal matrix. So ds1, Sj, dzj is the diagonal of the sigmoid of Zj. Yeah, it's a diagonal matrix with on this line here, the diagonal, you're gonna have the derivatives of the sigmoids with respect to Zj. So alright, we started with calculating the gradient of the cost function with respect to the matrix or the weights here W. And we came with this formula, then we derived ds4 by dw using the explicit and implicit terms of what we call the total derivative. And we got this formula. And then we expressed this term here more generally, call it dst by dsk. And then we just apply the chain rule, and we have a product of certain terms, dsj, dsj minus 1. Now we can take the derivative with respect to zj, and zj was the pre-activation. Yeah, so basically it's u xj plus w sj minus 1 plus b, which is the bias. So the derivative of zj with respect to sj minus 1 is simply w. Yeah, because there's only one j minus 1, so the derivative equals w. And this derivative, sj with respect to zj, we've seen this derivative here was the diagonal of sigma zj. Yeah. So where we had actually on the diagonal sigma prime, it's the derivative on the diagonal, and zeros out of the diagonal. So we're interested now in the size of dsj with respect to sj minus 1. Yeah, and that's the same as the size of the diagonal of sigma prime zj, yeah, times w, yeah, which is exactly this. Yeah, so we also know that the size of a times b is smaller and equal to the size of a times the size of b. Yeah, this is an algebraic law. So that means that the size here, dsj minus 1, is smaller or equal to diagonal of sigma prime zj, yeah, and the size of the magnitude of w. Now, sigma is always smaller or equal to 1, and we see that sigma prime is maximum 1 out of 4. Yeah, remember the sigmoid function is something like this, whereas the derivative of the sigmoid function goes a bit like this, yeah, and this is 1 out of 4, so it does not go higher. So this is bound. Yeah, there is a bound here, and let's call this bound gamma. Gamma is a bound, and it's smaller or equal than 1 over 4. Now, W is your weights, and your weights are also bounded. Yeah, So let's call this one lambda. Yeah, so that means that dsj over dsj minus 1 is smaller or equal than gamma times lambda. Yeah, so that is an important thing to know.